Steel production is a one-to-many production process. Primary steelmaking starts from iron ore or scrap. The blast furnace produces liquid iron from the iron ore. At the secondary steelmaking, the crude liquid iron is refined into a number of different steel grades, and the liquid steel is collected in a steel ladle. The ladle are moved to the casters and are cast into solid shapes of steel, such as slabs and billets. These rough shapes are further transformed into coils, plates, tubes and bars by processing them with different types of rolling mills. Once we reach the final dimensions, these steel products are further processed by various finishing processes such as annealing, galvanizing, painting, cutting, slitting, etc. So from one liquid iron process, thousands of different end products can be produced. On the production route from liquid to finished products, a lot can go wrong. Even the best producers daily face metallurgical defects or shape and surface defects. Also in the finishing phases, quality failures occur almost daily. These defects impact the business results of metal producers heavily, and so steel companies invest a lot into improving the quality and avoiding defects by introducing process control and quality control in the production and business processes. It seems that the 4 to 5% of defect rate is the best we can achieve by introducing production improvements based on direct production quality control measures. One of the reasons for this is that some defects only are detected later in the process, although the cause of the defect occurs earlier in the process. For example, a surface problem detected after galvanizing a coil can be caused by a strand cooling problem during casting or during slab reheating before the hot strip mill. But the physical defect detection occurs mostly late in the production process, and there is not so much you can do to avoid the defect at that stage anymore. Unless if you could predict the defect already after casting or hot rolling. So to reduce the defect rate lower than 5%, defect prediction as early as possible is required.